So this is where we left off in the previous video. We're now able to place all of our elements on the screen and determine the winner. And if we have a draw, if I can do this right, there we have it. Then our game notifies us of the draw. So now in the previous video, we left out one last step, and that is to determine our diagonal winners. So in this direction and in that direction. So this is called the main diagonal. This is called the off diagonal. And now we're going to change our code or add to the check winner function. So we cover for that case. Currently, we can check for row wins and column wins as well. So now we also want to have diagonal wins. Additionally, I want us to have lines over the winning column, row, or diagonal. So we'll get to that in a bit. All right, so let's get right into it. So now we just want to cover this part here where we deal with the diagonal. You can see that we still have that comment from last time. So let's cut that and paste it anywhere really, but let's start with it. So let's put it there. Okay, so we have to do a bit of math on this one, but it's not too bad, I promise. So if you look at the board, so I just want to run this again. If you look at the board, the diagonal basically starts there and goes all the way there. And I guess this will be more relevant when we get to the striking part of things. For now, let's just focus on what we did on the rows and columns. So for the rows, we just went through all of the rows, we looped through all of them, and we looked for one that had all X's or all O's. Then we also did the same for columns. So what we're going to do for diagonals is we're going to extract the diagonal and we're going to apply the same operations. So when we apply set, we want it to have a length of 1, and we want to exclude sets that have empty strings. So the diagonal should only have, so if you come back to the board again, let me just quickly run this again. So the diagonal should only have x's like this. So this will be applicable to that as well. So again, to extract the diagonal, here we're extracting the row, there we're extracting the column. Now we're going to extract the diagonal, the main and the off one. Then in that diagonal, we want to make sure that when we apply set, then the length is 1, and it's not a set of empty strings, but a set of either X or O. Okay, so that's exactly what we're going to do. So to extract the diagonal, we're going to use some NumPy functions. So to get the main diagonal, so we have to check for both. And this time we don't have to loop necessarily because the diagonals are just there and we only have 2 of them. So to extract the main diagonal, we're going to use this NumPy array which we have here. So board array dot diagonal, and you can check the NumPy documentation to figure out any other parameters which you might need for any other time. But for now, we're just going to call this function as it is now. So just your NumPy array dot diagonal. This extracts the diagonal. And I guess we can, let me see if this will be possible. But yeah, let's put a print statement here, just so we look at the diagonal at each time. So we can have something like this, an f string main diagonal, and we're going to pass in that variable in there. So we just want to print in our terminal what this contains at each point. So let's run our program quickly. Then when I place that, you can see that it prints out main diagonal. It has an X because that's what we have there. And then we put an O in the main diagonal. So this is the main diagonal. Once again, you can see that part there extracts this diagonal. And if I put an element there, you can see it's now X or X, which is exactly what we have in the main diagonal. So that's how that works. Just calling diagonal allows you to take everything. And as you can see, the output is a list or an array that has those values that are there. So initially it's just all empty strings because that's how we start with our board. And as soon as you start placing elements in there, then it gets filled up. Then this is the result of the main diagonal at whichever point that you are in the game. So as you saw, we had X, then XO, then XOX, and that's what we had there at that click, or after that most recent click. So this here, assuming that the diagonal is full, we'll have everything, and then we're going to make sure that everything in that diagonal is the same and it's not an empty string. But at each point, with each click, just like we have in here, it will call check winner whenever we click, and it will update the diagonal accordingly. So now we have the main diagonal, and we can also extract the off diagonal. And to do this, we're going to use this function called flip LR. So what this does is if you have, let's say you have 1, 0, 0 in the first row, then 0, 2, 3 in the second row, and in your last row, not 3, let's put a 0 there as well, so that's easy to see this, then 0, 0, 3. So if you apply flip LR to this, it is going to flip these elements to the following. You're now going to have 0, then the 1 goes there. So you're flipping the left and right directions. So what's on the left? Imagine a rod right in the middle that just flips this around, and your 1 is now on this side, your 2 stays the same because it's in the middle of the rod, and your 3 is flipped to this side here. So if you flip in any direction, left or right, then these will be the results. So if you flip R this, you get this. If you flip LR this, that's what you're going to get. So in our case, we are doing this so that this off diagonal now becomes the main diagonal because it appears that we don't have a function that extracts it directly like this. So this diagonal function only extracts this main diagonal, 1, 2, 3. But if we had the elements on this side and we were interested in extracting the off diagonal, we can't really do that. And if you just call diagonal, it'll return 0, 2, 0, even though we want 1, 2, 3. So to get the 1, 2, 3 that we want, which is the off diagonal, we're going to flip LR this so that that off diagonal now becomes the main diagonal. And this is what it looks like. At this point, we can now call diagonal, and that will extract 1, 2, 3, which is what we wanted from the off diagonal. So that's just an explanation of that. And once again, you can go to the NumPy documentation to find out more about this. So I'm going to flip LR this board array. Then after that, I'm going to extract the diagonal because the off diagonal now becomes the main diagonal. And so we can just extract it or take it out. Okay, then if you prefer to split this up, you can have this first just by itself. Then after that, you can apply this and assign that to off diagonal. And if you just want to do it all at once, like I did here, just copy this exactly as it is, flipping the left and the right so that the off diagonal becomes the main diagonal, then calling diagonal to fetch that main diagonal, which is actually the off diagonal. So now that we have both of these, we can apply the same conditions here as we did here. So these conditions are just going to check since both of these are now arrays that look like this, they just have elements in them. We can now determine if the elements in here are all the same or not, right? So if they are the same, then we have a diagonal win. And if they're not, then we just continue with the game. So we're going to check the main diagonal with each placement. So remember that check winner is called with each placement so that we can quickly identify the winner, or we can identify the winner as soon as they win instead of waiting for other moves. So this looks exactly like this, and I already explained this in the previous video. And if you haven't watched that, just go ahead and watch that to refresh your memory. Okay, so that's that. So we now have a main diagonal winner in this case. So if we have x, x, x in that array, for example, then set will give us just x. So applying set to that will give us just x, and the length of this will be 1. And this is not a set of an empty string, so it'll pass. So it'll go into this if statement. Now that we've passed that if statement, we are going to take any of the elements in that main diagonal because they're all the same. So if you have x, 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 they're all the same. You can take element 0, element 1, or 2, it doesn't matter. Just decided to take the first one in that diagonal. Okay, then updating our winner info. So now we don't have a row or column which won. So this won't be populated. We're only going to populate the other attribute in our dictionary, which is row call win. And this would be a main diagonal win. Remember, that's just a string which describes the type of win we have. So for the main diagonal, I just decided to go with main diagonal. And for the off, just decided to go with off. So you can change it to whatever you want, but these are just my strings. Okay, then I'm going to do the exact same thing for the off diagonal. So I have the off diagonal over there, and I want the length of the set to be 1. And the set should not be a set of an empty string. So that's what we're going to do. And now that we found a winner in the off diagonal, so it's very important that you understand that these two things can happen at the same time. So if the first person to win will be the only winner. So that's why we just have if statements for these. So if this person wins, then it's done. That's all that will happen, and this will fail. But if this person wins here on the off diagonal, then this would have failed. So it's very important to understand that. So if it's an off diagonal win, once again, I'm just going to take the first element in that off diagonal. Then I'm going to name this accordingly. So it's an off diagonal win. I just decided to use off, short, simple, and we are done as far as identifying the diagonal winner is concerned. So you can put that comment up there, make some space over there, just remove this white space there, and that's that. So we've identified the diagonal winner, whether it's the main or the off, and we have the row winner as well as the column winner. So now our quick task is to determine if this works before we go to striking through. Okay, so let's see if this works. So I want X to win on the main diagonal, and as you can see, it says X1. And let's try the off diagonal. So O1 on the off diagonal. So that looks fine. And the last part to close off the series is I just want a line to go over the winning row, column, or diagonal. So this is what I mean by that. So if this row wins, I just want a line to go through there to clearly indicate the row that won, and the same applies for columns and diagonals. So this is where the math comes in. Okay, so we're just going to create a function called strike through, and we can place it here, anywhere really. Let's call it strike through. And it is going to take in the winner info because we have to know whether we are going to strike through a row, column, or diagonal. So that's what this string was for. I'm pretty sure most of you are asking yourself why we have this string if it is never used, or why we're populating the winner info if we haven't used it thus far. So we're now finally going to use most of it, and this is the appropriate place. So if winner info row column win, so we have to have it in that form. So if we have a row win, we're just going to draw a line in the middle of that row. And we already know how to draw lines from the very first video of the series. And this is how you draw the line. But now you have to decide where you start and end. So if you remember, we have our grid, you can call it a grid. And in here, each of these is at 100. So this is 100, 200, 300, 400, and then the end is at 500. Then we have the other border at 0. So this is what we have, and we are saying that we want to draw a line that's in the middle of the row. And in the y direction, this would be 100, 200, 300, 400, and then the border at the bottom would be at 500. So this line, for it to be in the middle of this row or any other row, it would have to be halfway between 100 and 200, and that is 150 there, and here it would be 250, so that's where the line would be. This would be 350, so that's right in the middle of the row. So to do that, you can either manually type this out for each and every row, which I do not recommend, but you can do that. That's an option. You'd have to have an if statement for each row. So you check, is it this row? Then start here, stop there. Is it that? And so on. But if you want to cover all of the rows, that's when you have to do some mathematics. So this is the formula that we're using, but I won't go into much detail. This is just an arithmetic sequence formula, and it just describes the distance between these. So from 150 to 250, that's 100. From 250 to 350, that's also 100. So you can see that we're starting at 150 and we're just adding hundreds to get the next one. So that's the simple part of it. So to describe that, we're going to use our rows. And remember, our rows are labeled row 0, row 1, row 2, or at least in the code, we index each of the rows this way. So if I want 150 using this 0, I am going to have a 0 plus 1 multiplied by 100, then I'm going to add 50 to that. So this here gives me 100 plus 50, which is 150. And if I go to the second row, I will then replace that 0 with 1. Then I'll add 1 to it. So this is the placeholder box which we have, which holds the row. So that holds the row number starting at 0. And this stays the same everywhere. So this is our formula which you're going to use to determine where to start and stop. So in the second row, to get that 250 there in the y, we're going to have 2 times 100, which is 200. And this will give us 200 plus that, which is 350. So that would essentially be that one there actually. So this explains how you move in increments to get the y values specifically. So for the x value, the formula is similar, and we just have to calculate the y because the x is easy to figure out. So in the x, it's basically the same, it's just 100. And I just redraw this, so just go to a new page and restart. So in the x, it's really simple because in the x, that's just 100. So all of these points in terms of the x coordinates are 100. A point there also has an x coordinate of 100. A point there also has an x coordinate of 100 in terms of our Pygame plane. If you remember, this is what it looks like. So if we're at 100, all of them along this line will be at an x value of 100. But if you look at the y, it changes for each row. So that's why that calculation only applies to our y. So x is fixed as 100 as the starting point. Then we have to calculate the y for each of these. Then we just have to count to this point to figure out what x is. Well, it'll be 400 at that point because they're on the same line where our board ends. The next will be 500, which is the boundary. So once again, this has an x value of 400. That has an x coordinate of 400. The same applies there. And we just have to calculate the y's. And I already showed you how to do that, but I'll go through that once again. So we have the row number, and the row number we added to 1 because we start counting at 0. So this is row 0, this is row 1, and this is row 2. But we know that this is actually row 1, row 2, row 3. So to get it to those numbers which we use to count, we're going to add 1 to that. So 0 plus 1. Then we're going to multiply that by 100. Then we're going to add 50 to it. So this is 150. Okay. And the next one, we're going to have 1 plus 1 times 100 plus 50, which would be 200 plus 50, which is 250. That'll be the next row. So these are the coordinates. And as I said, you can manually put these in and just have 3 lines for each row, but that just increases the number of if statements that you have. And that would be that, and that would be that. And this formula here allows us to get all of those. And the exact same thing applies for columns. So for columns, we're just going to do the same, but we're now going to have definite y values because it's easy to find them. And we're going to calculate the x. So for rows, we fix the x values and we calculate what y would be. And for columns, you can see that we can easily find what y value that is. This is just 100. You can see that over there. The y value there is 100. Then, and so on. All of them here are actually 100, at the starting point. And you can count downwards. This would be 400. And you have to calculate your x just to have it in one if statement and calculate each as you need to. So if you need to go through this a couple of times, please do, so that you can understand why we have those calculations as we draw the lines. So let's continue. To draw the row lines, we're going to draw them on the screen, and we want our line to be red. And the line will start at an x of 100. Then our y value will be calculated. So that's why we have these brackets. And the calculation is we're going to use the row number. Then we're going to add 1 to that row number, multiply it by 100. Then when we're done doing that, then add 50 to it. And that gives us the y. And already showed you that the first row will be 0 plus 1 times 100 plus 50. That's how you get the 150, which is right in the middle of our row. Then this line will stop at this line. So just imagine typing all of this out for each row. So it'd say if it's row 1, then you'd manually put those lines in. If it's row 2, then you'd say 100, 250, then finish it off. So that would be 3 if statements for rows, and it'd be 3 if statements for columns. So this collapses all of your rows. This is it, and that's all that we have to do for all the rows. And we don't have to have multiple statements that treat each row separately. This mathematical formula allows us to avoid that. And it's going to stop at 400. So that's the x coordinate where it's going to stop at. And we're going to calculate the y position. And once again, we're going to use the row number, and we're going to add 1 to it, multiply it by 100, then add 50 to it. And once again, our line thickness will be 5. Okay, so I hope you're able to follow that, because it is out of the screen currently. Let me zoom out just a bit. That doesn't really help. But this is our line. Just drawing a line from 100. Then we calculated the y, and it stops at an x value of 400. Then we calculated the y once again using that same formula. Okay, I guess we can, since we like removing redundancies, we can create a function that does that calculation. So it's easier to do that. So let's call it calculate mid coordinate, something like that. Then it'll return, it'll take a number, which is a row or column number, and yeah, that's essentially it. So we can copy this, cut it actually. This is what it will return. And in our case, we will remove that and replace it with this. Okay, so that's that, and you can close it off there. So that'll multiply that. Then we're going to add 50 to that. Then in here, instead of having the calculation in there, we can just call the function so that it does the calculation for us in here. So calling the calculation function, and we're passing in row call number into that function. The same applies here. We're just going to call that function here. So it's just modularizing our code and yeah, preventing redundancies. So let me just fix this. And that's what we have. So we call that function there, and I just want to close that. And that looks close to me. So we're going to do the same for the columns. So we're going to say else if it was a column win, then we're now going to calculate the x. So we can figure out what the y is, because they all start and stop at the same y coordinates. And you can check this stuff out once again for yourself. So our line that goes from top to bottom starts at some x value that needs to be calculated. And we're going to pass in the column number, which will be used to calculate that x value. Now this is not cluttered with calculations. Then the y is known. It's just 100. That's where all of the column lines start. And this line stops at some value which we need to calculate. And once again, we're going to pass in that row column number, And now I'm just thinking of another way to reduce redundancy, which I just found. We could have stored what this calculation gives, because if you look at this and that, they're exactly the same. And so if they're the same, then we can just store that. So we can just say y coordinate or something like that and do it once there, calculate it once, then use that here. Hope you guys can appreciate that we are refining our code as we go along. And that would be it. Then the same applies here, which find the x coordinate using the same formula anyway. So there's no need to have this twice. So we store it there, and here we can just do that. So let's do that here as well. And the y coordinate here, the stopping point would be 400, and we have a line thickness of 5. So if you look at this, it's much more compact. It's nicer to work with. We have a function, and we don't have to have all of those calculations cluttering this stuff, and we don't have to call this twice, because that's the same calculation that would be performed anyway. So we can just store that value, then have it where we need it. And that's exactly that. So I'm very happy with that, and I hope you're able to follow along with the quick optimizations. So now moving on to the diagonals, starting with our main diagonal, we have the same story, but these ones are easier to work with because we can figure out what the coordinates there should be. So coming back to our diagram, or let's rather open a new page, if we have the grid like that, and we know that this point there is given by 100 in the x and 100 in the y, and we know that that point all the way at the corner there is, okay, let's fix our corner so that corresponds with the end of our board there is given by coordinates 400, 400. There's no need to perform any calculations. If our line starts there and ends there, that's enough to define it. If a line starts there at an x of 400 and a y of 100, and it stops there at an x of 100 and a y of 400, we've defined our lines. So this is the off diagonal, and this is the main diagonal, and those are the coordinates which we're going to use to describe them. So if we had a main diagonal win, then we're just going to draw a line on the main diagonal, and that line starts at, so this line will be drawn on the screen, it will be red in color, and it starts at, I've just described that. It starts at 100, 100, and it stops at 400, 400. You can just add some space for consistency, I guess. And I'll give it a thickness of 5. And the same applies for our off diagonal. So if we have an off diagonal win, then I'm sure you guys can see that we're finally using those strings now. We have a line which is drawn on the screen, and it is red in color. The line starts at the following coordinates. Starts at an x value of 400 and a y value of 100, and it stops at the following: x value of 100 and a y value of 400. The line thickness is 5. So we've now drawn our lines, and I spent quite some time explaining these calculations which we did for our rows and columns. And if we hadn't done these two, we would have had an if statement for each row and an if statement for each column. So that would have been 6 in total, so 6 in total, then plus 2, that would have been 8, but we now have half of that. So I think this is nicer to work with, but if you prefer, it's totally up to you. Have an if statement for each and every row. And that would mean that you check that it's a row win and the row number is 0. Row number is 1, row number is 2, and the same applies for column. You check for that, then you check if it's a 0, 1, 2, that's just too long. You can just use that row or column number, pass it in here, use it to calculate where we're supposed to draw our lines. So to close this off, let's test if this works, because we explained it all, we've seen it all, but does it work? So let's see if we have a diagonal win, we don't see that line coming through, and that's for a simple reason. We have not called this function. So let's come down here where we have a winner. We are going to now call that a when we have a winner, obviously. So display text has that other stuff in here where we display the winner and the winner is shown on the screen. Okay. So we can also add strike through there. Then we need to pass in the winner information into strike through, which means display text needs to take an extra parameter for that to work. So currently, display text only takes whether we have a winner or draw, then the person who won, but we also need to pass in winner information. So the winner information here will be empty, or it would be an empty dictionary. Okay, so to pass that empty dictionary here, so when we have a draw, we don't really have useful winner information, but when someone wins, then we have to pass that winner information through, which we've already initialized somewhere up here. But in the function, we have to update this function so that it receives that winner information. Okay, and then here, with strike through, it takes that same winner information, and that's how it's going to work. So check winner initializes the winner information with the row that won, and whether it's a row or column win, whether it's a main or off diagonal win. Then if we've identified a winner, then that same winner information that contains who won and where they won is passed to display text. And display text tells us what happened. If you have a draw, it'll say draw. There's no need to strike through in that case. Then if we have a win, then that's when we'd strike through. And so we have to have that condition as well. So this should only strike through if we have a win. So if win or draw is a win, then that's what we're supposed to do. We're supposed to strike through there. Otherwise, it would try to strike through even when you have a draw. So we don't want that. Now I'm just trying to think, but it makes sense to strike through if in the same if statement over there before we do all of this other stuff. I'm just trying to think, would it be best to do that? Let's try so that we don't have two if statements that evaluate the same condition. We have that same if statement up here. So let's see what happens if we just call strike through there instead of having two separate ones that do the same thing. So I've now called the function with winner information. Winner information tells you whether you have a row, column, or diagonal win, and where that win is if it was a column or row win. So I've placed that in there. Let's see what happens if we do that. So let's run it. Then let's start with the diagonal win. So there's an error, and the error says, what does the error say? So we've made a lot of code changes here, and all of this stuff is new. So that's why we're having new errors. So it's complaining about strike through, and we have winner info passing into that, and then strike through, we're evaluating all of those, row column win, okay, and what's wrong with that? Check winner, that, okay, doesn't really say anything. Key error, okay, okay, it appears to be a typo. Okay, so there's a typo in strike through, so let's just quickly fix that. Let's check here, row column number as well. Okay, and let me see if it is anywhere else. So I seem to have a roll call number and roll call win. Okay, I think I've covered most of them, if not all of them. And let's try that again. And you see that it strikes through. All right. So it was a typo, which I obviously missed. And now it strikes through in the main diagonal, and you saw that diagonal line. Let's check the off diagonal, and that's what it looks like. Strikes through right about in the middle of that, and it tells you that X1. Let's try the first row, strikes through there, tells you that O1, and in the second row, okay, accidentally 1 again in the first row. And in the second row, this is what it looks like. So you have to test all of them, because you can't just assume that if one works, then all of them will. So the third row works, and we can test the column, starting with the first one. First column works. Then moving on to the second column, that one works as well. Then lastly, the third column, let's try not to. Okay, and we have a win over there. So throughout this series, we've been able to build this from scratch. The first one, we drew the lines. Then the second one, we focused on placing items on the screen. The third one taught you how to determine the winner. And we continued that in this video with the diagonals and striking through. So I hope you guys learned something from this series. And this is a good introduction into Pygame, which you can use for multiple things. So you can make your own games now, and you can figure out how everything works with the help of the documentation or any other resource. So I hope you guys enjoyed the series. I enjoyed making it. And if you have any questions, absolutely any questions, feel free to ask them in the comment section. And like, subscribe. See you guys in the next YouTube series.